Welcome back to XSOAR Engineer Training. This is part 15, writing our first automation. In this video, we'll be writing our first automation within XSOAR, creating an automation script that will look up a user and a user's manager within Active Directory. And with that, let's get to it. Now the automation that we're going to be writing will be used as an instant action button. We already added a button back in video number 5, which executes the AD-GET-USER command from the Active Directory query integration. This allows our analysts to quickly look up a user's information within Active Directory while they're working the incident. But this only retrieves the information about the user. And while we have the distinguished name of the manager, what if we wanted, with one click, to allow our analysts to retrieve the user, their email, their groups, as well as the manager's name and email from that button? Well, that's where we can use an automation script to make that a reality. To create our new automation script, we'll navigate to the Automations menu and click New Automation. Now when naming our script, remember the naming conventions we covered back in video 6. Automation scripts should be title case, so we'll call this one AD Get User and Manager, and we'll click Save. When you create a new automation in XSOAR, you are provided with example code that dives into detail on the best practices for writing them in XSOAR. As XSOAR engineers, we highly recommend reviewing this sample as it can quickly accelerate your ability to write custom automations within XSOAR. Now, before we delete it and write our custom automation, we want to call out the links on the top, which reference the XSOAR developer site. This is your best reference for guiding you to writing your own custom automations as well as integrations. For now, we're going to remove the example code and review some of the common settings that are part of automation scripts. The default automation type within XSOAR is Python. However, note that you can also write automation scripts within JavaScript or even using PowerShell core. The main difference is that the Python and PowerShell core automations will utilize Docker containers to execute the code, while the JavaScript runs as part of the XSOAR server. For this, we'll be writing in Python 3, so we can leave it alone. We can give our automation script a description so that anyone who wants to use it, whether they're using it from within a playbook or the XSOAR CLI, will see what it's intended to do. Lastly, we can tag our automation with different tags and even create our own. Now, there are specific tags that are used for specific types of automations, and we'll be covering those in the following videos. For now, we'll save our automation, and remember, just like playbooks, save early and often. Now, before we start writing our automation, we'd like to cover a few important items that are good to know. First of all, the script helper. Clicking the script helper button will open up a flyout menu, which presents all of the functions that are part of the common server. If you are trying to accomplish something that may seem trivial, we recommend checking the script helper, as a function for it may already exist. For example, automations usually require us to pass arguments to the script. These will be used within the script to perform the functions for which it's designed. Now we can define the arguments for our script from the script settings. For example, in this case, we're going to require the email address of the user to look up, and we can click Add Argument to add the email argument into our script. In this case, we can also check that this is a mandatory argument, as we will require the email address in order for our script to function and look up the user. We can give it a name or a description, which details to anyone who might be using our script what this particular argument is for. There are other options that we can use with our arguments, such as specifying the options that would be presented in lieu of just using free text. So we could actually present a list and have the users pick the options and then use these within our script. And then lastly, we'd like to call out the isArray option. Now, as covered in a previous video, that is video 12 for looping, we know that XSOAR will automatically loop over arguments that are passed into scripts and integration commands as an array. The isArray argument stops this behavior and passes the entire array into the automation as a single argument. So if you do not want to have your automation loop over the items passed into this argument if they are an array, you can check isArray, which tells XSOAR to expect an array and not loop. Now that we've defined our argument within the script settings, we need a way to access the argument from within our code. Now for this, we can utilize the script helper. If we pop it open and search for arg, we can scroll through the list of available functions that we have to us. In this case, the args function returns a dict of the command arguments. We can even select copy to script to get the example code into our automation. We can also look at other functions we have available to us via the script helper. For example, the getArg function allows us to return the value of a given argument. Once again, we can copy this to the script and change it to suit our needs. To show you what this looks like, we'll just wrap these in a simple print statement. In this case, printing the demisto.args, and then adding in email to get the email arg. And once again, we'll wrap this in a print statement. Saving our automation, we can pivot over to our playground in another screen and test out our new script. If we do !AD get user and manager, you can see that the argument that we added as part of the settings is available, as well as the description. Filling in an email, we can just do james.bond again. We can hit enter, and we can see that we print the arguments, which are returned as a dict, which has each argument in it. If you had more than one, you would see multiple results here. And then using the getArg, we specifically retrieved the email argument and printed it out. Now both of these functions were possible through the use of the Demisto class object. All Python integrations and scripts have available as part of their runtime the Demisto class object. This object exposes a series of API methods which are used to retrieve and send data to the Cortex XSOAR server, such as retrieving the arguments that are passed into our script. You can review all the API methods that are available as part of the Demisto class on our xsoar.pan.dev site. However, there are two useful ones that we want to call out for your awareness. They are the demisto.incident and the demisto.context methods. The demisto.incident method retrieves the current incident and all its fields, such as the name or the type. In addition, incident custom fields will be populated a dict under the custom fields attribute. To show you what this looks like, we're going to comment out our arguments for now to prevent them from printing, and then we'll print the results of the demisto.incident call, as well as retrieve the name of the incident that it's running against from the demisto.incident object. Give this a save, and we can pivot over to an incident and run it in a war room to test. From our incident, we can pivot over to the war room and once again run our automation and giving it an email and see what we get back from the demisto.incident method. As you can see, we get the entire incident object back. If we were to go pivot into context, that's this one right here, which has all of the incident fields, as well as things like your custom fields. And we're able to call that from within our script. In addition, we were able to retrieve the name from the incident directly just by providing that specific field. So something to be aware of, if you need access to the incident itself as part of your automation, consider using the demisto.incident method. Next, the demisto.context method allows us to retrieve the context from our current incident. Once again, we'll print out the context that is returned from this and demonstrate within the war room. For now, we'll comment this out, which is basically command or control /. Give it a save and pivot over to our incident. We can use the up arrow on our CLI to quickly rerun the automation. In this case, retrieving the context objects from the particular incident. These are the things that are above our incident here in the context, the URL, IP, dbot score, etc. So if you do need access to the context of the incident from within your automation script, consider using the demisto.context method. Script we only need the email argument. So in this case, we'll remove our extra text here and paste in the text that will retrieve the email argument, storing it in the email variable, and we can print it just to make sure that we've captured it correctly. Which looks good. Now that we have our email argument within our script, we need to first retrieve the details about the user from Active Directory. Referencing our script helper, you can see that we have the AD-GetUser integration command available to us from within our automation. This is one key difference between automation scripts versus integrations within XSOAR. Integrations are designed to reach out to third-party systems like Active Directory, execute the command, and return the information from that. Automation scripts can execute the integration commands from within their code. If we scroll down on the AD-GetUser, we can copy this from our script helper to see the exact code used to execute this command. Now, in order for our automation script to execute this integration command, we need to provide the command the arguments it needs to run. In this case, our script helper outlines the various arguments that the command takes, which is the same as building it within the playbook editor. In this case, we'll be passing it the email argument, as that's the one we retrieve from our user. We can comment out our print statement and store the results of this in its own variable. Now, in order to return this in a way that XSOAR will understand, we can pass the user variable into the return results function. If we search for this, we can see return results, copy it in, and then pass in the user variable. We'll save and run it so we can explain what's happening here. Back in our playground, we can once again rerun our script from the command line interface. In this case, you can see that we get back the same results as the AD-GetUser command. Pivoting back, the return results function or method allows us to take the results of an execute command and return it to the war room, printing out the nice human readable markdown, as well as returning items from the command into context. In theory, we just wrote our first automation. In this case, we added arguments, which the user then supplied. We used those arguments to do something, in this case, executing an integration command. And then lastly, returning the results of that command to the war room as well as to context. We want our script to do more. We don't want just the user information. We also want information about their manager. And to do that, we need to explain what the results of the execute command look like. To explain, instead of passing the user variable to our return results, we're simply going to print it, give it a quick save, and execute this from our war room. As you can see, this item looks a lot different. This is what the return results function is interpreting for us. It gives us the information such as the module that executed the command and all the various metadata that XSOAR uses to return the human readable form, as well as the items to context. If we take this and put it into Visual Studio Code, we can get a better idea of what's part of this particular item. Taking a look at a formatted version of this within VS Code, we can see that XSOAR returned an array from that execute command, in this case containing a single item, which was the execution of the AD-GetUser command from our Active Directory query integration. This also contains things like the contents, which is the raw information that was returned from the command and which we as XSOAR engineers are interested in using in our automation script. Taking a look, we also see the human readable, which is how XSOAR produces the nice markdown table that we see within the war room. In addition, we see other items such as the entry context values that this particular item will place into context when it runs. But now we need to have our automation script grab this contents item, which contains the information that we are interested about the user, such as the display name, their email, their groups, and their manager. Returning back to our automation, we can use a little Python to grab that contents key from the user object. In this case, from the user object, grabbing item 0, and then getting the context key. We can use our handy print statement to make sure that we have what we're looking for. Give our automation a save, pivot to our playground, and execute it one more time. As you can see, we retrieved the dictionary that contains the information about the user that we're going to be using to build our own result and return to the war room. Taking a look at that raw response within VS Code, we can see that we have the attributes and account key, which contain the information that we're interested in. The reason we're doing this is to know from where in this dictionary we're going to grab that important information so we can construct our own response. In this case, we can see that the display name is under attributes, and tucked under an array of its own, we have the manager's distinguished name, again in an array of its own. By doing so, we know where we can grab these particular items to start building our own response. Build our own dictionary that we're going to be using as our result, starting with the user's details. In this case, we'll define a dictionary of our own with keys for the username, the user email, users groups, as well as the SAM account name, grabbing those items from our user object and from where they are within the user object. Lastly, we can use our print statement to print the result and make sure that everything is coming across as expected. From our playground, we can once again execute our script, this time noting that we're returning our own dictionary, which contains the information in our own keys that we're grabbing from the add-get-user command. Next, we can repeat our add-get-user call, this time retrieving details about the manager. If we add in some new code, we can see that we're going to use the execute command, again running add-get-user, but this time passing in the dn of the manager as our argument. As if you remember from the raw response, we only have the dn of the manager to work from. We can also efficiently grab from the response item 0 and the contents key. If we quickly comment out our code, we can test this once again using the print statement to make sure we got what we were looking for. If we run that one more time from our playground, we can see now that we get back the manager, in this case M for James Bond, which tells us that we got the right details that we can then add in to the result for our automation script. We can modify our result object, this time to also include the manager's name and email as part of it. Get rid of our print statement here, we don't need that. And we can paste in a new result object. In this case, adding in the manager's name and email, retrieving that from our manager variable above. Once again, we can use our handy print statement to help us debug and check our work. Running it from our playground, we can see that we get our object back, this time containing not only the user's information, but the manager's name and email address as well. So far this is looking pretty good. However, this dictionary is not super useful to our analysts. In addition, if we check the context, nothing is being returned from our automation and being placed into context so that it can be used as part of other parts of playbooks. For this, we need to modify our automation and use the return results function to return a result that XSOAR will understand. In order to construct a response that XSOAR will understand, building a nice markdown table displaying our results, as well as putting items into context, we can once again reference our script helper. In this case, we'll be searching for results, and the one we're interested in is the command results class. This allows us to construct our own response that we can pass to return results to return that nice item to the war room. This particular class takes a number of things. The outputs, which is the raw data that we want to return and set to context, which we already have in our result key. The prefix, where we want to put that in context, as well as other items like the readable output, which is a markdown string that will make our raw result look really great for our analysts in the war room. As always, we can scroll down and we can copy the command results into our script. Now to construct our command results response, we can review the various arguments that are required to be passed into this class and what they are used for as part of our script helper. However, to save some time, we're going to paste this in and review the most common ones. First, the readable output. This is the human readable markdown that will be used to return the war room entry. Next, the output's prefix. This is the context key that our results will be placed into under context. Next, the output's key field is the key in the result that will be used to determine if an existing item already exists in context, and if so, it will update that item. Next, the outputs themselves. This is the raw data. In this case, it's our result object that we constructed above. Lastly, we can tell XSOAR to ignore auto-extract on these results by passing in the ignore auto-extract equals true. Now the default is false, but if we want to control what is extracted from this, we can override it within our automation. Now if you were paying attention, and we sure hope you are, you'll notice that we don't yet have the readable variable, which contains our markdown. In order to generate this markdown, we can once again use a function available to us from our script helper called table2markdown. This function converts a raw object like our result into a pretty markdown table. We can generate our human readable output. We can replace our print command here. In this case, generating the readable variable by using the table2markdown function. This function requires the name of the table, which in this case we'll call it Active Directory User Manager Details. Requires the table itself, which in this case we'll pass in our result object. And then lastly, we can provide a list of headers that will be used to organize the data as it's displayed in the war room. If you don't provide the headers, then they may come out in the order that you don't want, so we can specify the order here. Lastly, we need to return our results, in this case here, to the return results function. Return results, which means that we should get a really nice human readable output to the war room, as well as the result object into our own context key. We can save our automation and give it a test from our playground. Back in our playground, we can run our automation one more time. In this case, you can see that we now have a nice human readable entry with our title and with the information displayed in the order we specified. This is where that table to markdown function is incredibly useful. If we check our context, go up here, we can see that our result object was placed into our AD user and manager context key. Again, displaying the keys from that within context. Returning back to our automation script, there's just a couple less things we need to do. First of all, under the script settings, we need to define the outputs that are provided by this script into context. This is done from our script settings, and we add in the outputs that our script returns into context. To do this, we need to define the context path that our outputs from this script will be placed into. In this case, we are placing our outputs under the parent key for AD user and manager. And then we can define the individual outputs that we want to make available. Doing this is what makes the outputs available from the playbook editor, which we'll show you shortly. So in this case, we can say that we're passing in AD user and manager.username and be aware that this is case sensitive. We can add additional outputs such as the user's email, and we can give these a description if we so choose. We've added in our remaining outputs and the context path for each. We've also provided a description for each one. But be aware, you don't need to specify an output for everything that you return. But let's demonstrate why adding these outputs is important in the context of building a playbook. Our new automation script can be leveraged within playbooks. If we add in a new task, in this case choosing our AD get user and manager script, we can see that the outputs that we defined are available here. Get user and manager. This means that in accompanying tasks, such as just using our print command, we have access to those outputs from within the Playbook Editor GUI. If we did not define those outputs within our automation, they would not be available here, which is why adding them, if you need this function, is important. We've built a pretty useful script here. Let's call it a couple other items that you should be aware of with automation scripts. From the script settings, you have the option to password protect any script you create, meaning that only users with the password will be able to execute it. You can also restrict scripts to being available only to certain roles within XSOAR, which is another useful feature. Lastly, our script relies on the AD-GET-USER command. Without this command and the integration that supplies it, this script would not work. In this case, we can define under this last section that our script will not work unless the AD-GET-USER command is available within our instance. If it's not, it won't display in our task editor or task library from our playbooks, and it won't be runnable from the XSOAR command line interface. Last thing we need to do is, now that we have a really good script, let's go modify our button to use it. From our layouts editor, we can select our button. Instead of using the AD-GET-USER command, which we had previously set up, we can have our button execute our newly defined script. In this case, it only takes one argument, which is the email address. We can save it and save our layout. And then we can pivot over to an incident and give this a test. In this case, it's now prompting us for our email address. We can submit it and pivot to our war room. We can now see that we have both the user details as well as their manager, giving our analysts more power at their fingertips. And with that, let's review what we did in this video. A quick review. When starting to write your own custom automations, remember the following. Review the sample code that is provided when you create that new automation. Remember to utilize the script helper from within the XSOAR code editor. It may help you from reinventing the wheel. Save your automation and test often. And you can utilize the out-of-the-box automations as a reference. Their code and their settings are available to you from the automations menu. Lastly, remember to check out the XSOAR developer site. XSOAR allows you to extend the platform by writing your own custom automations to suit your use cases, and this site is a fantastic resource. And with that, thanks for watching, and we'll see you in the next one.